Hello everyone, welcome to Coding Decoded. My name is Sanjay. Today I am working as technical architect at Adobe, and here I present solutions to weekly contest 3 or 4. The problem that I have chosen is longest cycle in a graph. Here in this question we are given a directed graph of n nodes where the IDs of these nodes lie in the range of 0 to n minus 1. Also, there's a very important constraint specified that each node can have at most one outgoing edge. What do we need to identify? We need to identify the length of the longest cycle that gets formed in this graph. If no cycle exists, then we should return -1 in those cases. So let's walk through an example. Here you can see there is one cycle that is getting formed between the nodes 3, 4 and 2. The length of the cycle happens to be 3, and since it's the only cycle in this graph, we have to return answer as 3. This is the length of the longest cycle present in this graph. And in case here in this example there is no cycle present, therefore we will return -1 as the output answer. Without further ado, let's quickly walk through the presentation section where I'll explain you the algorithm. Longest cycle in a graph, Leetcode 2360. It's a hard level question on Leetcode. However, I don't feel the same. I can categorize this under medium category. And for those who don't know me, let me just introduce myself. My name is Sanjay. I'm working as technical architect at Adobe. And in case if you have any doubt understanding this question, or if you want to ask anything from me in general, please feel free to drop a message on the Telegram group or the Discord server of Coding Decoded. Both the links are stated below. Now let's get back to the algorithm. I have taken a slightly different example so that you guys get a good hold of the concept. Here in this graph, as you can see, there is one cycle getting formed between 4, 5, 6 and 7, and this cycle starts from the node 1, and there is another cycle that gets formed between 5, 6 and 7. We are interested in identifying the length of the cycle. So we can either shoot for using the DFS approach or the BFS approach. Since DFS is easier to visualize, we will be using it in this example. So let's start the iteration. So right now we are at the first node. We will move in a DFS fashion, and as we progress, we will keep track of the distance of each and every node from the starting node itself. So right now the starting node is 1. So the distance of 1 from 1 happens to be 0. And remember, in the question it is specified that there will only be one outward edge exiting from each node. So from 1 there is only one node exiting, which is at 2. So let's proceed ahead. Next we'll have 2, and the distance of 2 from 1 happens to be 1. The distance of 3 from 1 happens to be 2. The distance of 4 from 1 happens to be 3. We are simply iterating in a DFS fashion, incrementing the distance value. Next we have 5. The distance happens to be 4 units. Next we have 6. The distance happens to be 5 units. The next we have 7. The distance happens to be 6. And let's hypothetically assume that there is another node, and that node's distance would be of 7 units from this first node. However, which is the outbound node in this case? The outbound node happens to be 4. It has already been visited in the past. And what is its distance from the first node? Its distance from the first node is 3. So 7 minus 3. So this was the expected distance. This is the actual distance. 7 minus 3 would give you the length of the cycle that exists in this graph. So if let's hypothetically assume this is the area of concern. So we are basically allocating distances to each and every node, and wherever you will see the cycle, wherever you will see that the node has already been visited in the past, at that point you can simply calculate the expected distance minus the actual distance from the source node. However, there is a slight trick to it. There could be a case where multiple cycles exist in the same graph. In that case, we should also keep track whether both these nodes belong to the same source ID or not. For example, in this case, the source ID happens to be the first node. Since both of them belong to the same source, they are part of the same cycle. So this is another constraint that we should think of while coding it up. Similarly, this is the second cycle that exists in the graph. So again, we can do the same kind of thing, start allocating distances from each node, and here in this case we can treat either the 5 as a source node, 6 or the source node, or 7 or the source node. It won't make any difference. So this is what I'm exactly going to do. So without further ado, let's quickly walk through the coding section and conclude it up. Here I've created an answer variable and initialized it to -1. -1 represents that there is no cycle in the graph. Moving ahead, I've created a map, and this map has 2 attributes. And each node of this map has 2 attributes. The first one is the source identifier, the ID which is acting as the source, and its distance from each and every node. here in this case I have used a 2D array for it, and the first index would have size as number of edges that we have, and the second index would have two attributes in it. The first one is its distance, and the second one is the source with respect to which the distance has been calculated. By default we have initialized it to -1, -1 across the array, entire 1D array. And let's proceed ahead. So I have created a for loop, and here I will represent each and every node acting as the source node. So it starts from I equals to 0, I is less than edge dot length I plus plus, and with each iteration we start from the default distance as 0. J represents the starting index while doing the DFS traversal. So in case my j, till the time my j is not equal to -1, what do? We extract from the cycle tracker what is the distance from the source ID. We extract the cycle identifier, basically the source ID, and in case my distance from the source ID is equal to -1, that means it has not been initialized in the past, and we assign a value to it. The distance value gets incrementing and source value gets allocated. The array object is created and dumped at cycle at the jth index. In case the distance from source ID is not equal to -1, that means there is some value. What do we check? We check whether the current element into consideration and the next element into consideration where we are moving to the next edge are part of the same cycle or not. We get it from the cycle identifier, which is acting as a source ID, is equal to the ith variable that we have, which is acting as a source again. If that condition is met, we check whether the distance value minus the distance from source, we subtract these two up, as I talked in the presentation, 7 minus 3, we get one possibility of answer, and we compare it with the answer variable, and we break out of this loop because we have identified the cycle. And since we are moving in a DFS fashion, j gets updated to edge.j for moving on to the next edge. Once we are done with that, what do? We simply return the answer variable. So let's try this up. Accepted. With this, we have successfully solved the last problem of the contest, and for the rest of the solutions, please find them in the first comment of the YouTube video.